Let's think about this. Quite frequently I see in your calculations numbers like this. Weight equals mass times 10. Or I see weight equals mass times gravitational acceleration. And then when you use numbers, let's say your mass is 10 kilograms, you say weight equals 10 times 10 equals 100 Newton. Or some of you write weight is 10 kilogram times 10 equals 100 Newton. Now this all is not correct, and I will show you why. Whenever you use equal, you say equal on both sides of your balance, both sides of your scale. It means when you put two apples on this side, you have to have an equivalent on that side. Let's say 3 weights representing the mass of the two apples. And this is for artwork. So if we follow this concept, then we can say we have on this side weight, and that equals mass times gravitational acceleration. If I go for the numbers, I can say on this side 10 kilograms times 10 meters per square seconds, 100 here. Correct. Now I can go for the units of measurement. They also must be equal. So I have on the right hand side kilogram times meter per square seconds, which actually gives me here kilogram times meter per square seconds. And some time ago we agreed internationally that we want to call this Newton, in appreciation of Mr. Newton and simply to make life a bit easier, because kilogram times meter over square seconds is a bit hard to say and to write. So Newton equals Newton, 100 equals 100, that's correct. Now let us go back to one of your expressions. Let us go back to this one here, saying weight is 10 times 10 equals 100 Newton. So I take my scale, good, go back to my scale, and I say on the left hand side I shall have weight equals mass times gravitational acceleration. Now by the numbers you say 10 times 10, and we have 100 here. Now by the units of measurement you give me 100 Newton here and nothing here. So that's not equal, cannot use. So you're really forced to carry along units of measurement. I give you another example out of the same. You say weight is mass times gravitational acceleration, and then you say weight equals 10 kg times 10. Now you say 100 Newton equals 10 kg times 10. Now let's look into this one. By numbers we have 100 on this side, 10 times 10, 100 on that side. Correct. By units we have Newton on this side, and mind you it's kg times meters over square seconds. That's square seconds here. And on the other side we only have kg. How can it be that kilogram, kg, on one side equals kilogram times meters per square seconds on the other side? Not good. So you can say, well, this is a mere formality. It doesn't really matter. Well, I tell you how much it matters. Many of you will have to deal with American aircraft, and Americans still live in a slightly different world. They give us the mass in pounds rather than kg. Now let me give you the example. My mass is 92 kilograms. If I go to America, they say my mass is 202.4 pounds. If I follow your calculation, you say my weight would be my mass times 10, which would be 92 kg times 10, and for a miraculous reason you change this now into Newton. The result actually is correct, but we don't get there in the appropriate manner. I'll show you why. You forgot that my mass was given in kg or in pounds. So we do the same calculation and say my weight is my mass times 10. And I give you my mass as 202.4 pounds times 10 equals 2024 Newton. Now these two are not the same. So here's our problem. Living in an aerospace environment, living in aviation, you have to deal with odd units of measurement. Pounds, pounds per square inch, slugs, all kind of funny things which we do not use in the metric Western world, but the Americans still use it, and about 50% of aircraft production and research and development comes from their side, so you have to live with it. Good to know, not to remember. I show you the extreme. The Americans calculate with the mass in pounds, so in my case 202.4 pounds. The gravitational acceleration is not 9.81 meters per square seconds or roughly 10 meters per square seconds. No, this one is 32.17 feet per square seconds. You notice they don't make a big difference in terms of time, luckily. So if we calculate the weight now, it turns out, change color just for the fun of it, weight equals mass, 202.4 pounds, times 32.17 feet per square second. That is 6,511.2 pounds feet over second square. Now, as odd as it may look like, this result is identical with that one. So, with all the right in the world, I can write this number equals 902 Newton. I can do this because I distinguish between Newton and pound feet over second square. So, lesson learned, you need to carry along units of measurement for any calculation you do. You cannot omit them any given time. And that's the way it is.